Let's be real for a second. Is your aquarium truly safe the minute you walk out of the room? For so many of us in the fish keeping hobby, there's this underlying constant anxiety. You know the feeling, that creeping fear of an unnoticed temperature swing just frying the tank, a sudden leak draining gallons of salt water onto the floor, or some dosing error happening while you're stuck at work or fast asleep. We pour so much time, money, and, quite frankly, love into these aquatic ecosystems, yet they are incredibly fragile when we just leave them up to chance. Welcome to The Explainer. Today, we're diving deep into the world of aquarium automation and controllers. Our goal over the next few minutes is to look at exactly how we can transform that fragile glass box of yours into a highly robust, actively managed system. We're going to explore how modern technology basically takes the guesswork completely out of reef and freshwater keeping. We're talking steadier conditions, fewer missed maintenance tasks, and some serious heavy-duty protection against equipment failures. Here's a quick roadmap for today. We'll start with the core of tank automation. Look at why stability and safety have to come first. Break down how you actually choose the right platform, examine some really common automation workflows, and then finish up with smart setup best practices. All right, Section 1, the core of tank automation. The big three. When you strip it down, every modern aquarium automation platform really revolves around blending three essential functions: monitoring, control, and alerting. The sheer beauty of bringing these three steps together is that your system can react to a problem in mere minutes. It can automatically make adjustments or even shut down a failing piece of equipment entirely, rather than waiting hours for you to happen to walk by and finally notice something looks a little off. Just think about the immense breadth of what these ecosystems centralize. For monitoring, you're tracking critical parameters in real time: temperature, salinity, pH, and ORP, which is a measure of your water's ability to break down waste, along with detecting physical water leaks on your floor. Then, control takes over your actual hardware, your heaters, chillers, and your dosing and return pumps. And finally, alerting ties the whole thing together. You get push notifications, emails, or even loud audible alarms the second parameters start to drift. You are basically pulling every single sensor and outlet into one hub to run strict logic-based routines. Moving right along to Section 2, stability and safety first, protecting your livestock. Consider the stark contrast between the old-school way of doing things and the modern way. Relying solely on a basic built-in heater thermostat is honestly a massive risk. We all know they notoriously stick in the on position, rapidly heating up and literally frying a tank. But when you route that exact same heater through a smart controller's logic, the controller is the boss. It stages responses and completely prevents that rapid cycling disaster by cutting the power at the outlet the very millisecond the temperature goes out of bounds. And it goes way beyond just heaters. Controllers provide this immense baseline stability. Even tiny, seemingly insignificant swings in temperature or salinity can deeply stress your livestock and complicate your reef's overall health. By enforcing strict lighting and feeding schedules, reacting instantly to real-time sensor readings, and providing redundant safeguards like dedicated leak detection, you ensure that small, stressful swings are stopped dead in their tracks. Because let's face it, your corals are probably more dramatic than a reality TV star when their daily routine changes. A good system will physically shut down an overflowing skimmer and ping your phone before a drop of water hits your drywall. Okay, Section 3. Choosing the right platform, buying criteria. When you're out there comparing different platforms, please don't get distracted by the flashy marketing feature lists. Focus on practical day-to-day capabilities. Does it actually have the sensor support for the measurements you care about, like dissolved oxygen or pH? Does it have enough outlet and relay capacity for your specific list of equipment? You absolutely need reliable automation logic, stable networking so you can check your remote dashboard from anywhere, and expandability. The smartest choice is always a system that handles your current hardware perfectly, but leaves you enough headroom to add, say, an automated water testing module or a new top-off system down the line. Let's look at Section 4, common automation workflows, real-world applications. The first real-world application here is incredibly simple, but man, is it highly effective: gradual lighting transitions. Now, while every tank's lighting setup is different, you can dramatically reduce livestock stress by programming lighting schedules that smoothly ramp up in the morning and dim down at night. It perfectly mimics a natural sunrise and sunset, completely eliminating those sudden, jarring bursts of light that spook your fish and shock your coral colonies. Now, here's a slightly more advanced workflow, but it is an absolute lifesaver. You can pair your standard temperature control with what are called duty cycle alerts.
Basically, you set an alert to trigger when a heater's or a chiller's duty cycle exceeds a safe threshold, meaning the equipment is running way longer than it normally should just to reach its target temperature. This acts as a brilliant indirect early warning sign that your equipment is starting to fail, or maybe a window got left open long before the actual temperature of your tank crashes.
Dosing chemicals requires a lot of extra care, and controllers add some incredibly vital guardrails right here. You can literally program the logic to cap the maximum dosing allowed per hour. Better yet, you can tell the entire system to just pause everything if the pH sensors read out of a specific safe range. This totally minimizes the risk of a runaway dosing event caused by a piece of drifting equipment, stopping a full-blown chemical overdose dead in its tracks. Finally, we have Section 5, Smart Setup Best Practices, Phasing in Automation. Look, this automation tech is incredibly powerful, but it is so much easier to get right when you build it out in stages. Start small. Begin with just basic monitoring and non-critical control, like getting your lighting schedules dialed in. Only after you've thoroughly verified that your sensors are accurate and you've watched how your outlets behave, should you move on to step 2, automating those highly sensitive functions like dosing and auto top-offs. And then finally, step 3, and this is crucial, you must test your failure modes. Testing those failure modes brings us to the absolute golden rule of aquarium automation: notify and move to a safe state. You need to know exactly what your tank does during a network outage, a power interruption, or if a sensor accidentally gets bumped and disconnected. In a properly designed setup, the default behavior should be highly predictable. It should instantly send you a notification and power down any critical systems to a safe, neutral state. The last thing you want is your controller blindly running heavy equipment based on bad or missing data. Now, as much as we all love having an automated tank, we have to acknowledge a hard reality. Calibration and old-fashioned maintenance still matter. While this is incredible technology that heavily reduces the chance of missing a big issue, you still have to do your periodic physical checks. Over time, sensors are naturally going to drift and they'll need recalibrating. Return pumps will wear out. Dosing tubing will inevitably clog with calcium. Your controller is an amazing assistant, but it's not a replacement for your own 2 eyes. As these smart ecosystems become more affordable and accessible, the whole mindset of the modern hobbyist is shifting. By aligning your automation with your personal priorities for stability and highly dependable alerts, you elevate your tank. It goes from being a passive glass box filled with water to a truly managed life support system. Your software logic, your real-time sensor data, and your controlled equipment are all working together seamlessly to sustain life. So I want to leave you with this one final provocative thought. Take a look at your current aquarium setup right now. If a catastrophic failure occurred this very second, a heater sticking on, a PVC pipe bursting under the cabinet, what is your system's automated safe state? If the honest answer is that it doesn't have one, it might be time to look into bringing a controller into your ecosystem. Thanks so much for joining me on this explainer, and I will see you on the next one.